So one of the problem that we'll be encountering, no, plus, from my previous lecture, no. So what we have here is the solar heat gain for maximum. So this is for we call it yung solar heat gain factor mo is available only for 32 degrees north latitude and 40 degrees north latitude, which is if we going to look sa Google Earth yung ano na yan, latitude na yan that we have here sa Google Earth. So dito tayo, okay. So it is only ang sinasakop is part ka ng US. So that is one ano na all this, the data is kulang, no. We have 35, 45, 55, pero ito meron ako nakitang data nito, but the rest yung pababa starting we have here starting at the call this 6 degrees, no, 6, 7, 9, 10, 11, 13, 15, 17, 19. ASHRAE does not provide the data for this one, but there is a calculation, no, that we can use in order to determine how much is the radiation flux doon. And we will introduce the equation. So we'll be putting the new equation. By the way, this is the ano pala, no, we call this yung itsura na what we're using shading coefficients, no. We have the Venetian, so ganito ang itsura niyan. So ilagay ko na rin dito so that you will be aware kung ano yung itsura na sinasabi ko. So shading coefficients ng Venetian blinds, ito yung usually blinds. So malaking impact siya para makatulong maka-reduce ng solar radiation. And also we have yung tinatawag na roller shades. So yan. Okay, so you have the roller here, then pwede mo taas baba. Okay, so it is a one way to decrease the solar radiation and solar the convection and heat transfer of the outside temperature to the inside, especially if you have plenty of glass na usually mga high-rise building or office building, so or hotel, so they provide glass yung wall, okay, ay yung wall niya to usually paikot, okay. So yan yung itsura, and this is the one way to decrease ng heat transfer. So I will be introducing yung total shortwave wavelength irradiance. We have the symbol which is yung ET, no? Then we call this we have your equation. This is defined as your ET, total irradiance, is equal to your EDN. So we'll put here the definition later. Then we have your ED, so you define as the diffuse of the sky radiation. And we have your ER, so ER is defined as the solar radiation reflected from the surrounding. Then we have your EDN, defined as the direct normal irradiation or the solar irradiance. And you can check the further explanation of this equation on the ASHRAE fundamentals. So that will be in the chapters so that is already will be clearly explained in chapters 29 and 30 for the penetration. You can check that one if you have your copy of Ushering Fundamentals, 1997, 2000 to 2001. Also, you can use that one. Just look for the fenestration chapter. We have the total heat admission through the glass, so that will be equal to the solar heat gain plus your conduction heat gain. So we'll focus on, since dito madali lang naman itong makuha. Okay? Now we'll be focused muna ito since it is wala tayong mapagkunan ng table. Okay? So this equation can be written as you have here the Q absorbed, so usually the unit will be watt per square meter, no? So that will be the flux. So we have your equation, solar heat gain coefficient, no? Multiply by your total ET. So yun doon sa taas. So the total short wavelength irradiance. Then usually kung conduction, that will be plus, no? Plus the U. We have your change in temperature, T outside, and yan you have your T inside. Since we'll be focusing only what we have, ito we can compute it directly na rin eh. So ito na lang we'll be focusing in this one. So since we'll be removing on this one, we can remove that one already, no? Itong part na ito. But it will be included. So in a separate sheet calculation, you can do that one. We'll be focusing on the solar heat gain, this one purely. Okay, so we have the value, we can compute the ET. So since we have different, no, different requirements to get your ET, so we have your EDN cosine theta, then we have your ED diffuse sky radiation, then you have your ER solar radiation. Then for the solar heat gain coefficient, where your solar heat gain coefficient, ang unit niyan is dimensionless, usually walang unit. Okay, we'll introduce new equation na tawag na we call this the apparent, no, the apparent solar. Let's erase this one. So this will be the apparent solar time, AST, to the local standard time, LST. I will introduce new equation for this one, where our AST is equal to your LST, local standard time, then plus ET, the equation time, and decimal in minutes. So you have your ET, equation of time, divided by 60, then plus the local standard time meridian, that will be decimal degrees of arc, local standard time meridian, LSM. Then we have minus the local longitude decimal of arc, we have LON. Okay, then this is divided all by 15, no? Then we have the following definition for your AST, the apparent solar time, that will be expressed in decimal hours, and the LST, local solar time, decimal, also expressed in decimal hours. Then we have your ET, equation of time, this also expressed in decimal minutes. LSM, so local standard time meridian, that is expressed in decimal of arc. Then we have your LON, or LON, local longitude decimal, so expressed in decimal degrees of arc. Okay, so for determining the solar angle, no, where the sun's position in the sky is sometimes conveniently expressed in terms of solar altitude, so that will be the above horizontal, no, and your solar azimuth, were measured from the south, no? So these angles in turns depend on the local latitude, and you have your solar inclination, which is also a function of date that will be shown on the table later on. We have the hour angle. Our angle is expressed as the 15 that will be multiplied by apparent solar time, AST, minus 12. Now, to determine the solar angle altitude, so we have the equation that will be the cosine of L times the cosine of this one is the position, no? Solar declination, and multiply it by the cosine of our angle, then plus the sine of L, then the sine of the inclination, that will be the sine of the solar declination. Now for the azimuth angle, we have angle to determine that will be the cosine of the solar azimuth, then it's equal to the sine of the solar altitude angle, then sine of the, which is your L, is the latitude given to the problem, or what location your latitude are including with. Then we have your sine of the declination, solar declination, then divided by the solar altitude angle and multiplied by the cosine of the latitude. Then we have here the definition. So L for latitude, solar, we have this symbol, solar altitude angle. Then this one for the solar declination angle. H is for hour angle. Then the solar azimuth angle. Now for the representation drawing, no, we have this sketch drawing, no. So you have here the solar altitude angle. So then this solar azimuth. Then we have your normal to the vertical surface. You have your P. Then we have here the west and the east. You have the north and the south. So you have also here the vertical surface and the tilted surface, and you have the horizontal surface. Then you have the sun, which is emitting the heat. So you have your earth sunlight, okay, from here, OQ. Then you have your other thetas of value. Okay, you have your theta here the azimuth, and okay. Now for the direct normal irradiance, so at the earth's surface on a clear day, direct normal irradiation is expressed in this equation. That will be your A, the apparent solar irradiation of air mass, which will be located on a table from the ASHRAE. I will lagay ko rin naman siya dito. Then you have the value of UV, the atmospheric extinction coefficient, so that will be also in the table from the ASHRAE. Bringing down the table 8, no, that will be the extraterrestrial solar irradiance and related data. We have your table 8. Then you will notice here the values of your A, B, and C. So your B and C are dimensionless. So we have your A, which is the apparent solar irradiation, no? Okay. Then the declination degrees. So this corresponds to the symbol declination degrees, so we correspond to this symbol. Ito, part na ito. Okay. And then we have your atmospheric extinction. That will be yung B. So ito yun. The extinction coefficient that will be also found in table 8. Okay. So ito yung table na data na yan for table yung B and A, B, and C. So it will be the dimensionless. So this one also. Okay. Now for the diffuse and ground reflected radiation, we have your Y ratio that will be defined as the ratio of the sky diffuse radiation on a vertical surface to the sky diffuse radiation of the horizontal surface. Now, we have this Y is equal to equation of 0.55 plus 0.437 times the cosine theta plus 0.313 cosine of squared theta. So that will be the value for cosine theta, which is greater than negative 0.2. Now, if your cosine theta is greater than equal to less than or equal to negative 0.2, you can use the Y is equal to 0.45. Now for the diffuse regions, ED is given by ED that will be equal to your C times the Y times the EDN for vertical surfaces. So the value ng C is from the table, no? Ito yun, okay? So this one, C. Then your Y depends on the cosine theta. And yung EDN also is, we have your equation din kanina, diba? You can still remember kung saan natin nakuha yon. So EDN that will be from here. So dito, so your EDN, so from here, okay? Then we have your EDN that will be equal to Z times your ED, that will be EDN, that is multiplied by 1 plus the cosine summation of theta divided by 2 for the surfaces other than vertical.